Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Today we are going to learn about one more conic section, that is ellipse. An ellipse is the locus of a point which moves in such a way so that the sum of distances from two fixed points called foci is constant. Or we can say that an ellipse is the set of all points in a plane, the sum of whose distances from two fixed points in the plane is a constant. Let the two fixed points are f1 and f2. Let p1, p2 and p3 be any three points on the ellipse. Then, by definition, the sum of distances from point P1 to the two fixed points F1 and F2 is equal to the sum of distances from point P2 to the two fixed points F1 and F2 is equal to the sum of distances from point P3 to the two fixed points F1 and F2. That is, P1 F1 plus P1 F2 is equal to P2 F1 plus P2 F2 is equal to P3 F1 plus P3 F2. Okay? Also, the midpoint of the line segment joining the foci is called the center of the ellipse, and the line segment passing through the foci of the ellipse is called the major axis of the ellipse. Here, the line segment AB is the major axis. Also, the line segment that is perpendicular to major axis and passes through the center of the ellipse is called minor axis. And here, the line segment CD is minor axis. Also, the endpoints of major axis, that is A and B, are called vertices of the ellipse. Let length of major axis, that is length of AB, is equal to 2 times small a, and length of minor axis, that is length of CD, is equal to 2 times small b. Clearly, small a is greater than small b. Also, let f1 is at the distance of c from origin and f2 is also at a distance of c from origin. Then we can write coordinates of f1 as minus c comma 0 and coordinates of f2 as c comma 0. Since length of major axis is equal to 2a, therefore each vertex is at a distance of a units from the center. Thus coordinates of vertices are minus a comma 0 and plus a comma 0. Since length of minor axis is equal to 2b, therefore each endpoint of minor axis is at a distance of b units from the center. Thus coordinates of endpoints of minor axis are 0 comma minus b and 0 comma plus b. Now let us define latus rectum. Latus rectum of an ellipse is a line segment perpendicular to the major axis through any of the foci and whose endpoints lie on the ellipse. Now, length of latus rectum is equal to 2b square divided by a. If major axis of the ellipse is along x-axis and minor axis is along y-axis, also center of the ellipse is at origin, and length of major axis is equal to 2a, length of minor axis is equal to 2b, then equation of ellipse is x square by a square plus y square by b square equal to 1. Now, if major axis of ellipse is along y-axis and minor axis is along x-axis, center is at origin, and length of major axis is equal to 2a, length of minor axis is equal to 2b, then equation of ellipse is x square by b square plus y square by a square equal to 1. Or we can say that if denominator of x square is greater than denominator of y square, then major axis is along x-axis and minor axis is along y-axis. And if denominator of x square is less than denominator of y square, then major axis is along y-axis and minor axis is along x-axis. Okay? If length of semi-major axis is a and length of semi-minor axis is b, and each focus is at a distance of c from the center, then relation between a, b and c is a square is equal to b square plus c square. Now we will define the eccentricity of an ellipse. Eccentricity of an ellipse is the ratio of the distances from the center of the ellipse to one of the foci and to one of the vertices of the ellipse, and it is denoted by small e. Therefore, small e is equal to c divided by a. Now, in my next lecture, we will do questions related to ellipse. Till then, take care of yourself. Thank you.